at the USGBC California event to learn about how we can make our buildings more energy efficient, more healthy, and particularly to this community, more resistant for fires. And to do that, we need to escape from the way we've been doing things before. We cannot be prisoners of our old building practices, and we need to move to a golden age of high performance buildings. As you know, locally made products is a passion of mine. And you might think it's odd that I'd be interested in speaking with you today about another window company. But here is John of Fenster, who is making North American made, high performance, passive house quality wood windows and doors. John, thanks so much for meeting with me and talking about your windows and doors that you're making. So, you're doing European style systems,
Yes, sir.
making them in Vancouver.
On Vancouver Island.
Yeah, and nice place to be.
Yes, it
Wow,
is.
yeah, making windows in paradise.
Yes, sir.
Look at this. Look at the cork he's got here. As you can see here, with the different ways he's putting the wood together, that's going to minimize the shrinkage and the expansion of the wood. And then he's got this nice thermal break here with the cork. He's getting your triple glaze. He's got aluminum cladding. So really an appropriate product for passive house.
I agree. I mean, the interesting thing about this too is that this is all manufactured from product that is harvested probably in the neighborhood of 200 to 300 kilometers from where we manufacture it. Absolutely sustainable, and we've been doing it for hundreds of years. We've got a lot of trees up there, so you'll notice too that on this aluminum clad, it's actually not touching the wood. It's actually held off the wood, so it becomes more functional as a maintenance issue or longevity, or more importantly, a color. You can color this just about whatever color you want to have.
So the cladding's not touching the wood, so
No,
it
sir.
allows for a little ventilation behind
Correct.
there.
So no water will get down and stay down in there. It just flows all the way through.
Oh, that's nice. That's clever. So what do you do for your screens? Because in Europe, like, screens are a complete afterthought, but I see
Yes.
you have a screen here because we
Well,
do have insects in North America.
We do. We have some big ones in Canada. But nonetheless, we try to make it as simple as possible. This screen is detachable. Just simply, if you want to take it off in the wintertime, you can. And then when you reinstall it in the spring during bug season, it just simply goes on. Standard. And when you look at it from the exterior, it fits beautifully with how the window functions. Simple frame, simple solution, and it works wonderfully.
And this is a PHI certified
Yes, sir.
component for cold climate.
Yes, sir.
I love my UPVC windows, but they're not the solution for everything. And sometimes, you need historic windows,
Yes.
or even things that function like an historic
Yep.
window, but need the performance
Correct.
that for a passive house project.
Correct.
And these are things that you guys are comfortable
Oh yes,
with doing.
we've done it and we can do it.
I'm glad to know you're out there, and we're both here providing solutions for folks who want to build better buildings and need better windows and doors here in North America.
Agreed.
So,
Hey, anytime we can help, let us know.
all right,
Thanks, man.
likewise.
Appreciate
Thank
your
you.
time.
The embodied energy in Portland cement, and then when it's mixed with aggregate to make concrete, is a huge impact on the amount of CO2 that's generated each year. It's somewhere about 8% of the global CO2 is coming from Portland cement. And so solving that problem, coming up with alternatives to get the structure that we need out of concrete, but with something that has a lower embodied carbon. This is a problem that a lot of different people are working on. And I come across this company today called Secrete, which seems to be offering an interesting solution. Let's learn more. Who's Ben? How are you?
Good, how are you?
I'm very well, thank you. Normally, we have limestone. It's got to get heated up. Tremendous amount of temperature, a lot of energy baking that. What are you guys doing differently?
So thank you for asking. This is a very important problem. So what we do is the innovation is based on two major changes. One is removing the limestone as a feedstock. So far, for 200 years, limestone has been the dominant raw material for making cement. But now since 2023, we started using different feedstock and granite, basalt, or zeolite. These are all natural non-carbonate rocks. So in their chemistry, there is no CO2. So we are solving part of the problem. The other major innovation we are doing is removing the kiln and mainly pulverizing rocks and using some chemical methods to make them cementitious. So, and as you may know, the kiln is also a huge source of contributing to the CO2.
Right, that's a great point. I didn't mention earlier is that when you also uh, mill up the limestone, you're actually releasing CO2. But you were saying with those other stones, there isn't CO2
Exactly.
inside. Wow.
So
So it's a double problem: the heating of the limestone and the limestone itself.
Exactly.
Yeah.
Where we have removed both of
And
them.
and now they're both gone.
That's why it's called it cement-free concrete, because there is no Portland cement in the binder. So our binder is mainly based on natural rocks or industrial byproducts, and same performance and same cost. So ideally, no brainer.
How scalable is what you're doing here?
So scalability is a very big issue for cement. So from the onset, we make sure that it's scalable, and we already have poured more than 3,000 tons of our product in the market, and now we are at next stage to go 100 tons of the product. Yeah.
And some of the most scared, conservative people I know are engineers.
Yes.
They're very comfortable with what they know. And so, how do you get them to accept and spec your product?
So what we do is show them a few standards that we have met. A key standard, one of them is called 1157, like ASTMC 1157, that we are meeting this standards. The other is if they are very conservative, we do a mock-up for them so that they see the product in a real setting, a small setting, and they feel the material, test it any way they want. And some past projects we have done, there are some of them shown here, show them these projects and they are standing up, to what the spec was supposed to be. So that way they get comfortable, and then we found that as more and more projects we do, the market become more comfortable.
And then it comes down to the question that's always on the mind of the GC: cost.
So cost is also very important for a commodity like cement. And so what we approach is almost same cost as Portland cement or comparable cost. And the reason is that some of these rocks we are using are very cheap, just like limestone. So we can compete with the cost. And I would say these two factors, plus scalability is the main, these two factors, cost and scalability is the main thing that any new cement technology should have. And we are targeting both to be comparable to the conventional cement.
And what would you say to conventional companies that are saying, well, listen, we're sustainable, we're mixing fly ash and slag in, and, it's like over 50%.
So those are great initiatives, but they only do partial replacement. Let's say 40% slag or 50%. Still 50% of the binder is cement, and still 50% of the emission is going to the air. But what we do is 100% replacement. So nothing can beat that. Like if you remove 100% of the cement, then all of a sudden, almost 800 kilograms CO2 is eliminated because cement is very polluting, and that way, you can have a much better impact to the environment.
And so, this is going to be on the internet. People are watching it all across the country. They could try and find ready mix places across the country, or is this more regional right now?
No, we have done projects across different states. So if they contact us, we can find the nearest ready mix company to that project and work with them to provide the concrete to their job site. They just need to arrange with us in advance. Yeah.
Well, really interesting, and I wish you the best of luck because it really seems like a very interesting solution for a very important problem.
Thank you. I appreciate it.
Thank you. So mass timber's been in Europe for a long time, and it's making its way here into the U.S. And we are with a mass timber producer, Smart Lamb, and let's learn a little bit about it. Hi, Elise. I'm Darren.
Hi, Darren.
So, why are people interested in mass timber? What do we need to know about it?
Yeah, it's a great sustainable alternative to steel and concrete for tall wood construction. There's carbon sequestration that happens when we store carbon in the wood as part of the built structure. It's a renewable resource, and there's also speed of construction that can be realized because of the prefabrication element. There's a lot of time that's saved on site.
Yeah, because you have those CNC machines in your factory that can mill out all the holes for the MEP, for the electrical stuff, and then you can just everything's labeled, and then you snip them right together on site.
Yeah, that's exactly right. So there's a shop drawings that we coordinate with it's generated from our 3D model that is coordinated with the MEP system. From those shop drawings, we code our CNC programming to cut out all of those openings, prefabricate everything. Everything is labeled with like a QR code. And then when it arrives to site, it's placed, usually takes like 20 minutes, 20 to 25 minutes to place each panel. So there's speed of construction with that.
And you could build really any kind of building type out of these. I mean, there's people doing mass timber high rises.
Yeah, so up to 18 stories in the IBC is allowed. But yeah, so tall wood construction, mid-rise construction, even single-story construction. So all sorts of project types.
But I don't want to build a building out of wood because it's going to all burn down.
Yeah, mass timber operates a little differently. I'll show you our sample to demonstrate. So a char layer will form. So during a fire event, it's about 1.5 inches per hour, a char will form. And so the panel itself is designed to inherently incorporate that char layer into the design so that the panel won't fall down and it can resist that fire.
Because it's the density so that there's no oxygen in there, so that the fire can't proceed going through. It doesn't have any oxygen to feed off of.
That's right. Yeah, so heavy timber construction operates differently than like conventional wood framing. It operates more like a tree in a forest, where if you think of a forest fire, the outside of the tree chars,
Right.
but the inside actually doesn't, and it's the exact same for CLT and mass timber in general.
Now the panels clip together. What is that panel to panel connection like? I mean, how do I make sure that I get great air tightness?
Yeah, so there's a few different options for that. There's like a plywood spline is pretty common conventionally. Simpson just came out with a great strap that just goes right over the top, connects the panels together, transfers horizontal shear, and then usually there's some sort of like topping system for acoustical treatments, and then also like the finished floor to provide that air tightness.
What about the thermal performance, high performance? Because as you know, my passion is passive house.
Uh-huh.
How do I use mass timber in a passive house construction?
Yeah, so that's a great question. So it just has the R value of wood. So I think it's about 1.25 per inch or 1 per inch. So that's really the thermal value. Oftentimes there's additional insulation that's added to kind of add extra insulative properties.
For sure, but it's also great in terms of it's giving you structure. You're gonna make it your air tightness layer. Then you add that exterior insulation, and then you can leave the interior natural,
Yeah, exactly.
or if you don't want to, in certain areas you can fur it out and do whatever you want.
Yeah, exactly. So oftentimes we'll see it like exposed in like living spaces, but if there's a kitchen or a bathroom that has more MEP systems, then they'll soffit those areas just to hide those utilities.
Yeah. So you have 2 plants here in the United States, one in Alabama and
one in Columbia Falls, Montana.
and then your wood is all FSC certified?
No, it's not all FSC certified. We do offer FSC chain of custody certification as well as SFI chain of custody.
So people have that option.
Yeah, they have that option. So depends on the project type, but oftentimes people opt for FSC or they just want SFI.
And what are the difference in the capabilities between the 2 plants?
They're pretty similar. The Dothan, Alabama plant manufactures with Southern pine primarily. It's right in the center of the wood basket for Southern pine. So we work really closely with Southern pine mills down in the southeast. Up in the Pacific Northwest, we're manufacturing with Western species. So that's Douglas fir, spruce pine fir, and hem fir.
So it's more about distribution having the 2 plants.
Yeah, exactly. Distribution and then being kind of centrally located to where we're sourcing a lot of our wood.
There's so many different ways to find your path to passive house. Now here in California, I see a huge push of people wanting to get into passive house for resilience. I'm here today with Brian from the Passive House California to speak with us about how passive house can help make their homes more resilient and, as you phrased it here, smoke tight.
Yeah, passive house is a great way to become resilient, and for so many reasons. Um, we're definitely in an area where we're seeing a lot more stress from different ecological issues, climate issues. So wildfire is a big issue, not just from the actual fire, but the smoke pollution, and also the warming climate. We're seeing a lot more heat events. Long term, 10 day, 2 week long heat waves, and issues with power outages because of wildfires as well. So looking to be resiliency is really a big issue.
Yeah, and so a house can be destroyed during a wildfire not only because it burns down, but because smoke gets into the house and really can cause some serious damage. And so, if you have an airtight building,
Well, it helps reduce the amount of smoke and pollutants that are coming in, especially like you're saying, the particles that damage your building. As things get burned, especially buildings, you're putting out a lot of toxic materials into the air, and that soot coming down inside can just destroy the building. Can become like a hazmat situation, basically.
but passive house can also help stop that fire from getting into the house in a few different ways as well. Because like one of the ways fires get into the house is through the embers that go through these like ventilated attics. Passive house.
Yeah, embers are overwhelmingly the primary way that structures get ignited during these events. And so doing passive house allows us to do construction without ventilation, enclosed crawl spaces or attics. And so eliminating vents helps. Also, just the airtightness of the building helps also keep embers from penetrating in different cracks and aspects like that.
And then also the second biggest way that houses can catch fire is with the thermal stress that happens on the windows, and the glass cracks, and the fire comes inside, and then the house catches fire from the inside out.
Yeah, definitely. So you're talking about radiant heat, and that's a big issue, especially if you're in a urban situation. So like we've seen, whether here, Northern California and Santa Rosa area, or just this past January in the LA area, a building that's just 10, 15 feet away from you that's burning will help. It can either crack the glass, explode the glass, so then you get embers coming in through that area, or it just creates such a heat on the inside through the windows that, like you're saying, it brings up that material, say like curtains right at the window, brings it up to the ignition point and starts burning the house from the inside out.
And with a passive house window, it's going to be much more airtight, and you're going to have triple pane glass, and so it's going to be much more resilient to that thermal stress.
Yeah, definitely. You get basically three layers of protection versus one. If it's a 1920s house, you have a single pane glass. A more modern house with double pane, and also even some of the coatings that we use nowadays help repel some of that heat.
Great point.
Yeah, the low E coatings.
And the spacers too. I mean, some of those older spacers are aluminum, and those are very conductive.
Yeah.
So all these things that we take for granted with just trying to achieve the passive house standard are going to help with these very urgent needs, and when we're thinking about rebuilding here in California from these fires and really elsewhere around the nation.
Yeah, definitely. I think so.
What are we looking at here?
This would be a standard house built to California code, the current code, and this is about represents how much air leakage you would have.
I mean, that's just like way too much air flowing through your house.
Right.
But this one's a lot smaller.
So if we went to a passive
Not
house,
as much air. Well, Brian, thank you so much.
Oh, you're welcome. Pleasure.
It was really nice being here today at the USGBC conference in Northern California to learn more about their concerns with wildfires and their local solutions. But at the heart of the matter is climate change and how it affects all our communities in different ways. It, in your area, it may be droughts, or it may be heating loads and cooling loads. We all have to come up with different solutions, and Passive House can be part of that solution. And there may be other building techniques and other building materials that get incorporated. But for me today, after a long day of learning, I have this West Coast IPA as my solution.